Wandering Yeti, representing earthbound astrology, signing in to explain the phenomenon of eclipse, particularly the eclipse that we have coming up on New Year's Eve, which is a partial lunar eclipse. Try to explain how this happens with the convenient little 3D model I have here. So you can see this little knob right here, a little knob down here, representing the axis of rotation of our home world. This ring represents the ecliptic, which is the word to which the word eclipse is related. And that's because the ecliptic represents the plane of Earth's orbit. If you were to draw a disk, make a disk out of this path that Earth traces around the sun, she goes this way. That disk is called the ecliptic. It moves through space with the sun, so we trace a spiral. But anyway, the sun is always shining on the ecliptic. If it's northern winter solstice with the north pole pointed away from the sun is still shining on the ecliptic. And then if it's spring equinox, the sun is still shining on the ecliptic, but the axial tilt is pointed this way, so the ecliptic is also, this point is also the equator, so we get equal day and night, equinox. Northern summer solstice, we have the north pole pointed toward the sun, south pole pointed away, and Libra, the fall equinox for the north, spring equinox for the south. Again, we have the ecliptic and the equator intersecting at this point. So the moon is not always conjunct the ecliptic. She has what are known as nodes. So we can see this this piece of metal right here can represent the sign Cancer, Capricorn, and Cancer. And then we have Aries and Libra. Right now, we're just a few degrees into Capricorn. So the sun will be shining this way at the time of the eclipse. Now, right now, the moon's nodes, which are the points on the ecliptic where the moon crosses north or south. In this case, the moon is orbiting like this. The nodes are always 180 degrees opposed one another, and they cycle through the zodiac like this. They make a complete circuit in about 19 years. Right now, they're at 21 degrees of Cancer and Capricorn, respectively. The eclipse is going to happen at 10 degrees Cancer and Capricorn. The closer you get to the nodes, the more exact the eclipse. When you have a total lunar eclipse or a total solar eclipse, then you have the sun and the moon both conjunct the ecliptic, and so they're both on the same level. It's like sun, earth, moon, and so earth casts all of its shadow onto the moon, or the moon casts all of its shadow onto the earth from this direction, which will be coming up next, towards the end of January. So the eclipse that we have coming up, Sol's gravity pulls on the southern hemisphere more directly. And the eclipse is partial because right now the Arctic in the north of the Arctic Circle, this is what the Arctic circles mean. North of the Arctic Circle, right now, it's dark 24/7 because the tilt away from the sun, Gaia's shadow is like this, and there are points north of the Arctic Circle where the whole top of the planet is nighttime for a few months every year. Meanwhile, in Antarctica, it's 24/7 daylight for a little while longer. So, The eclipse is not the moon. The moon will be approaching her south node, which is where she crosses. Um, this is the south node. See, she's crossing south, and then the north node, she's crossing north. So she's just going to be just a little north of her node, which would be right on the ecliptic. Meanwhile, the sun is always right on the ecliptic because the ecliptic is defined as Earth's orbital relationship with the sun. The moon, on the other hand, is out here and just a little above, enough above that even though part of the northern hemisphere is always dark, the moon is far enough away from Earth that some of the sun's light will shine over Earth and illuminate part of the moon. If the nodes were in a different position, or if the eclipse happened in a different position where they were closer, the shadow would totally cover the moon. And so that's the way it's going to happen. And it happens, so we've got where I live, the left coast of Turtle Island over here, it's going to be just before noon when the eclipse reaches exactitude. And over here in Africa and Asia, it'll be, the moon will be in their sky, so they'll be able to see the eclipse. And so that's how it works. Hope that clarifies things. Hope it wasn't too confusing. I find it easier to explain these things with 3D models than in text. Wandering Yeti signing off. See you next time.